All right. So we're starting off on this one with the exponential equation base 5. So you know for a fact that the inverse should be a what type of function? A log, and what should the base be? 5, yeah. So if you see any other multiple choice answers that don't have log base 5, they're probably not going to be it. So remember, to find the actual inverse of an equation, you interchange x and y. So f of x is just a fancy word for y. So if you want to prime the pump, per se, by just calling f of x y to begin with, that's not a bad first step. And then the money step, the real critical step, is interchanging x and y. So now you got x equals 5, y minus 4, plus 3. All right, so from there we got to peel back the layers and resolve for y. So first thing we need to do is what? We're trying to solve for y. Yeah, we need to get the y down, but we can't get the y down because right now we have the plus 3. So you always want to isolate the variable term first, and then the variable factor second. So we got to subtract 3. So x minus 3 equals 5, y minus 4. This should be a piece of cake after you just did that logistic algebra. And now we have isolated the exponential factor. If there had been like a value of a in front, like 2 times 5, we would need to divide through by the 2. But it's just a 5. So now we can take the log of both sides. And because it's base 5, we'll take log base 5 of both sides. So we get log base 5 of the quantity. And then on the right side, log base 5 of 5 to the blob is just a blob. And now you're almost there. Now you just add 4 to both sides. And you get your final answer, y equals log base 5 of x minus 3, and it becomes plus 4. And now that you've done that, you've solved for y, you can kind of rename it f inverse. We started with f, so this would be f inverse. And you're done. So now you just look for that as an answer choice. Let me give you one to practice on your own. Very similar here. Let's do g of x equals, and I'll throw a few more things in there. How about 3 times 1/2 2x plus 1 minus 4. There you go. That one has an a, a b, a c, and a d in it from the standard transformation form. So go ahead and find the inverse of this function g of x. All right, some of y'all are finishing up. Let's go for it. G of x is y, so you can skip that step of calling it y if you want to and just call it x. And then you got 3 times 1/2 of 2y plus 1 minus 4. So again, our goal is to first isolate the term that has the variable in it, which is that one. So we'll add 4 to both sides. And once you isolate the term with the variable, then you want to isolate the factor with the variable, which is that. So now we need to get rid of the 3. So you can divide through by 3 if you want. That's fine. I'm going to multiply both sides by a third. So I'm going to leave that as a third times x plus 4. But you could also have x plus 4 all divided by 3. And that just equals then the 1/2 to the 2y plus 1. So now if this were algebra 1, you'd be done. But now we have to unexponentiate it once you get the exponential factor by itself. And since it's base 1/2, we'll log base 1/2 both sides. And we're left with 1/3 x plus 4 as the argument. And that equals 2y plus 1. So you don't really have to show the process of doing it to both sides. It's kind of an algebra 1 thing. You could just actually go from one line to the next. And now it's pretty easy. Now we need to get y by itself. So we'll subtract 1 and divide by 2. So when you subtract 1, you get the same left side, but now a minus 1, and that equals 2y. And when you divide through by 2, I'm going to put the y on the left, and I'm going to call it g inverse. So instead of dividing the whole thing by 2, we'll just multiply both sides by another 1/2. So we'll have 1/2 log base 1/2 of 1/3 x plus 4, and then minus 1. Or you could have this version as well, which some of y'all probably did. 1/2 log base 1/2 of x plus 4/3 minus 1. Either one of those. On a test question for a multiple choice, I would probably pull the 1/3 out front like that because it puts it more in like standard transformation form. But there you go. So if you could do that, you've got one of your questions tackled for tomorrow. But instead of giving you an exponential and have you find the log, I may give you the log and have you find the exponential. Yeah, go ahead and take a picture. There you go. Bonus. Sorry I wasn't in it. Okay, over here now. So here's another g of x. This is a log base 5, and we're trying to find the inverse function. So it should be exponential base 5. So 5 to the something. So first step again is replace your x and y or interchange them. So if g of x is just y, now it's just x. Log base 5 of 6y plus 4 minus 3. All right, so here is the variable term. Got to get it by itself, so we add 3. And now we get the factor by itself, but the factor is already by itself. So again, if there had been a coefficient in front of the log, you would now divide both sides by it. But since we have the log isolated, bless you, now we'll exponentiate both sides. And you don't even have to show that. You could put the 5 down here on the bottom left, but you don't have to show that. That's just kind of an early stage kind of helping thing. You could just call it 5 to the x plus 3 equals 6y plus 4. 5 to the log base 5 of blob is blob. Now you subtract 4 and divide through by 6, which is the same as multiplying by 1/6. So you get y equals 1/6. Now here you don't want to mess up at the very end. You multiply the whole left side by a 6. So technically it's got to be in parentheses like that. And now I'm going to give it the name g inverse, and I'm going to do one other thing as well. I'm going to distribute the 1/6. So you get 1/6 times 5 to the x plus 3rd power minus 4/6, which is really 2/3. And there's the inverse. All right, so one more, and we'll call it a set of notes here. Let me give you one to practice. Let's call this one h of x for ho 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 of x. Let's put some extra stuff in there. How about a 4/5 log base 7 of 3x plus 1? Or let's do 3x minus 1. Ooh, even better. And then plus how about 8, as in like 88? There you go. Find h inverse. New box of tissues over here, if you need them. Okay, let's go over it. H of x is now x, and x is now y. So again, the first task is to isolate the term with the variable. So we got to subtract 8 from both sides. And then once you isolate the term with the variable, you have to isolate the variable factor, which is the log itself. So instead of dividing by 4/5, because it's a fraction, I'll multiply both sides by the reciprocal, 5/4. So we get 5/4 quantity x minus 8 equals log base 7 of 3y minus 1. And now we've got the log isolated. So now we can unlog it. So it'll be 7 to the 5/4 quantity x minus 8th power equals 3y minus 1. And that's the least you have to show. And now we're just going to add 1 to get 3y. And instead of dividing both sides by 3, I'll multiply both sides by 1/3 and call this one, since I called it what, h, we'll call it h inverse. And you end up with a 1/3 quantity. Here's again where you don't want to mess up. If you just leave the 1/3 in front of the first term and you keep it as that plus 1, in other words, if you have this as your answer, that would probably be an answer choice on the test tomorrow. You actually have to do one last step and distribute the 1/3. So you get 1/3 times 7 to the 5/4 x minus 8, and then plus 1/3. And that would more than likely be the answer choice that you're looking for. Okay? So there's two versions of each one, starting with exponential and going to logs, starting with logs, going to exponential. You can take a picture of that one, Maru? Okay. All right, good. Okay, so the only thing left here is solving literal equations, but it's just manipulating letters around instead of numbers, and we just manipulated 4 different equations, so we could skip that. This one down here would be similar to the one y'all just did on the free response. It's kind of a logistic-looking thing. The equations, we solved them through 7D yesterday. That's going to be sufficient enough. You're not going to have to do something like this where you have, notice your logs are different bases. You're not going to have to do something like that. It's pretty straightforward. Just remember tomorrow when you're solving a log equation, you have to test your answers out at the end by plugging back into the very original and make sure that they give you positive arguments. So your test tomorrow, the second part of it, you want to go ahead and write this down. You'll have 30 minutes, and I'm going to stick to that, because it should be enough. If you practice enough tonight, 30 minutes should be more than enough time. You're going to have 10 multiple choice questions. Of course, it's going to be sections 4.1 through 4.4, and there's no calculator. So to practice, of course, you can look at all the worksheets again, but look at all the old tests from 4.1. There's, I think, 4.1 to 4.2, and then you got 4.1 to 4. I'm sorry, it's not 4.4, it's 4.5. Then there's another set of old tests that go 4.1 to 4.5. If you look at the multiple choice questions on those parts that don't require the calculator, like if you look at the top, it says calculator permitted, you're not going to have to practice that one for tonight. So here's one that I would not give, okay? If you have an initial quantity of 30 grams and it triples every 3 hours or every 4 hours, let's say, then the equation for that would be 30 times 3 to the t divided by 4. What would be the population of the substance when t equals 100? Okay, because then you'd have to go y of 100 equals 30 times 3 to the 100th divided by 4. And that's not going to give you, I mean, you're going to get a decimal answer, and so I'm not going to ask you a question like that. It's going to be more the manipulation type stuff. All right, so look for old tests with no calculator required, and if you want to practice all of those, remember the key is posted for those old tests. All right, and then we'll combine the two tests, the one from today and tomorrow, and that'll be your second to last test grade.